All right, so here's your favorite or least favorite part. So we're actually going to create that rough sketch, right? Because part 2 says you want to create that rough sketch using the integers you identified in part 1. Okay, so first things first, over here, you've got this new equation, right? It's the one that's up top that we created. Notice the 36, notice the -1. Okay, if I were to factor this, I would get 36 up in the top, and then I would get -12 in the bottom. What two numbers, if I multiply them together, I would get 36, but add them together, I'd get -12. That's going to give you -6 and -6. It's the same thing that we had over here. Okay? So if I actually factor this, that means, I do the whole box method thing where I put the first term in the first box, last term in the last box, and I put these two terms here and here with an X slapped onto them. And I take out the greatest common factor of the columns and rows. So what do they have in common? An X. What do they have in common right here? A -6. What do they have in common here? An X. And they have a -6 right here. So you'll notice that this will become X minus 6 squared. And we still got that -1 out front. Over here, we're going to have same kind of setup, but A times C is going to be 10. And B is going to be -7. All right, so we need to think, what two terms, if I multiply them together, I'll get 10, but if I add them together, I'll get 7. Well, that's going to be 5 and 2, and they're both going to be negative, and the reason why is because there's a -7 down here, right? We can't say 5 plus 2, and that give us -7. All right, so now we're going to do the box method. So put it in our box. Our first term goes in the first box, and our last term goes in the last box. And these two terms that I just found, I'm going to slap an X onto them and put them inside the box. Now I'm going to take my greatest common factor. So out of here, what do they have in common? An X. Out of here, what do they have in common? -2. Here, X. Here, -5. So now I have X minus 2 and X minus 5. Okay. Now do you remember back when we were talking earlier, we were talking about the Intercept format in our activating strategy, right? That intercept format, right? So over here, I can say that I have an intercept at +5, +2, and +6. So here it is again. I have x-intercepts at +2, +5, and +6. And I'm going to draw those on my little sketch. 2, 5, and 6. Now remember, I want my thing facing downwards, right? Okay, so I know that it can't touch this quadrant, right? Like, we can't touch this quadrant because it said in the directions that we can't touch quadrant 2. So I know that it at least has to start going up this way, because if it was facing the other way, it would cut through quadrant 2, right? So it has to be facing downwards. So the arrow is going like this. Okay, and at some point it's going to come back down, and then we're going to finish downwards. And the reason why I'm going to know that we're going to finish downwards is something called end behavior. And I think y'all started talking about this a little bit later in this unit in particular. But with end behavior, we can tell from the exponent. Okay, so remember we had our exponent was our 4th degree. Okay, so that's an even numbered exponent. And we know that our leading coefficient is negative. So since it's a negative even, it's going to have an end behavior of negative infinity and negative infinity. And we're going to talk about that in the next couple of videos. Don't necessarily have to worry about how high this goes. It can be kind of inaccurate. That's okay. Remember, this is just a sketch. We want to just know roughly what it looks like. And even if your sketch doesn't look exactly like this, that's okay. I know, I think after my first period, you probably want to take a look at this again. But we'll see in the next couple videos.